thank you all very much for joining day 2 of the second Industrial Ethernet Week from Harting. Yesterday we already had a great day, and I hope many of you joined us already yesterday, but I would like to give some organizational input also for those who are joining for the first time this morning. In the chat box of the GoToWebinar meeting, you can ask questions. We will bring them to stage as far as possible. If this is not possible from timing reasons, we will pass them to the speaker and you will get an answer afterwards. Also, you will find a link in the chat box where you will come to a landing page which will give you the opportunity to directly contact us here and agree on an appointment if you have particular projects, particular questions regarding the content of the sessions or regarding, which we love most, connectivity challenges you would like to have solved. So now the second day is all about infrastructure. We need the infrastructure, we need to connect all the devices, we need to connect the field level of the factory, of the shop floor to make the IoT happen. And all this won't work without the right testing methodologies. So if you have connected everything, but you need to test that everything is running, and for this, I'm really happy to have Fluke Networks here with us today on stage. And we will hear in the next 20 minutes about maximizing your industrial Ethernet cabling and connectivity uptime. Uptime, I think, is a very important keyword. It needs to run, and how you make sure that everything keeps running will be explained by Riccardo and Nigel. Please join me on stage. Thank you so much to be here.
Good morning.
Guys, thank you for your commitment. Stage is yours, and looking forward for your insights.
Thank you very much.
Thanks. Good morning, everyone. Me and Nigel are very happy to be here today at Harting. We are going to talk indeed about how to maximize your industrial Ethernet cabling and connectivity uptime. And we are indeed from Fluke Networks. This morning we will also present the new cable and network tester for the first time in Europe, and Nigel, we will show you the details. So Fluke Networks is a part of Fluke, and actually this year we are celebrating our 75th anniversary, and for 75 years our motto, our mission is to keep your word, your plant, your process up and running. And what it means, what can we do for that? So basically we produce test and measuring devices and products that are able to measure critical parameters that describe well the condition and the status of a process, of a network, of the industrial Ethernet network. Because when it comes to industrial Ethernet, we have discovered that 40% of the downtime issues are caused by the cables, by the connectors. So we need to take a very deep look of what we are doing when installing a cable and connector in the field to support the industrial Ethernet application. So the first thing, of course, is to properly install the right cable, the right connectors. We need to verify the material compatibility based on the environment where the cable is installed. The type of cable, strand cables, especially when it comes to have an application with a lot of movements. Even thermal resistance is an important aspect to consider. And also when it comes to connectors, we need to consider in which area the connectors are. For example, if there are moisture, there is a condition of high humidity or particles, we need to have a very well protected connector. Or even when it comes to have a lot of vibration condition, we need to probably use an M12 or an M8 connector. So this is, of course, the first best practice we need to have when it comes to install the correct cable assembly. But after that, we need, of course, to test, to be sure that we eliminate all the potential causes of a downtime. We have 3 different types of testing procedure. The first one is the verification. This is the simplest type of test, and is just testing the cable continuity, so basically checking that the cable is not broken, and verifying the wire map. So basically verifying that the pins are correctly assigned to the right wire. A level deeper in the testing part is the qualification. So basically beside the wire map and the continuity, we are going to measure the length. A very important parameter, the length, sometimes even underestimated. Especially when it comes to hot environment, the length can be a very critical aspect to consider. We know that the signal strength decreases when it gets very hot. So we know that there are some processes that are running at high temperature. So a very important aspect to measure. A qualification tester also measures the bandwidth. That's also a very important aspect because it tells us which is the bandwidth that typical installation is able to support. But qualification doesn't test anything against an international standard. That is the certification level where we need to follow specific indication given by the international standards. And here I'm indeed putting on the slide the most important international standards where we have the limits. So we go to name very detailed parameters like insertion loss, return loss, next, and the standards is telling me which is the level that I need to guarantee to have a proper installation. So we always say that a category 6 cable with a category 6 connector with a category 6 installer doesn't mean that the final installation is a category 6 installation. Only a cable tester, only a cable certifier can guarantee that we are meeting the right performance. And then, of course, we need to follow the industrial Ethernet protocols guideline given by the industrial Ethernet bodies. It's very important that we also know when is the right time to make a test. Can be just after a simple field termination assembly. We need to be sure that the wires are correctly placed. We need to be sure that we are untwisted properly the cable, because of course, if we have an untwisted pair, this is maybe a cause of noise entering the cable. Shield integrity. We sometimes underestimate how the shield is important. We need to be sure that the shield is continued, is completely connected with the connectors and then to the rest of the installation to avoid the ingress of electromagnetic in our system. And then, of course, after we install a cable, we need to be sure that the cable is not installed. So when we are going to place the cable in a plant, we need to be sure that the cable is not broken when pulled through conduits, through different compartments of a plant. And then, of course, the third moment when we need to test a cable is when there is an operation failure. It's a matter of going there and troubleshoot if the cable is indeed a source of downtime. Where? We have two locations basically where we need to test a cable is at the machine builder when we are manufacturing an important machine, so by the OEM, or after at the plant when the machines are delivered and are then reassembled. And here it's very important to document all the test results to prove that the installation has been properly done, that all the parameters are correctly met. So after having presented very shortly the best practices and where and when we need to test the cables, let's talk with Nigel which products we need to use to properly test an industrial Ethernet installation. Go ahead, Nigel.
Thank you, Riccardo. Good morning, everybody. My name is Nigel Hedges, and it falls to me to deliver the technical part of the presentation. So when we're talking about certifying industrial Ethernet cabling links, what do we use? And the short answer from Fluke Networks is to use a DSX 5000 series instrument with the correct adapters, which you can see here in the image, for the different types of connector which we're using. This is a very high specification tester used very strongly by the installation engineers and technicians when they are installing the cable. We can also add fiber optic options if required. One of the challenges that we face as a manufacturer of test equipment is the utilization of these different types of connectors. RJ45 is the most familiar to us, but we have M8, we have M12 in 2 different variants, and more recently even, we have the iX industrial connector specifically from Harting. All of these adapters are available for the top of our tester. When we're considering the connectors, we also have to consider the different cabling configurations. And one of the challenges we face is that there isn't a tester on the market at the moment that can actually read the color coding on the cable. But what we can do is confirm that the twisted pairs are correctly terminated at both ends and terminated to the correct pins. We can measure insertion loss, we can measure near-end crosstalk, which is a fancy name for noise, and we can measure return loss, which is a fancy name for echo. All of those parameters are required for certification of a cabling link, and in order to test them effectively, yes, we use the certifier, but we also have other options. Our most recent addition is this special wire map adapter, which is a 4-sided adapter, which enables us to test M8, both variants of M12, both the 4-pair and the 2-pair variant, and RJ45, all from the same adapter. And we use this together with 2 different instruments, the first of which is a verifier. This is a non-reporting tester, which is called Microscanner PoE IE, Industrial Ethernet, measures distance or length of cable in meters, also distance to fault. It works on cables with RJ45 connectors and on M8, M12D, and M12X adapters. It has a built-in tone generator to trace cables, and it will identify PoE. Has the advantage that it's a very small piece of test equipment, but it does not report. More recently, we've introduced the Link IQ IE. This is a new product. In fact, this is its first public appearance in this form, and this is our qualification tester. So it checks cable termination, it confirms the available bandwidth in terms of the applications to be used, it provides network switch connectivity data and tests for the presence and capacity of remote power, or PoE. All of that data is then saved for report generation and documentation at a later stage. If we're looking specifically at Link IQ IE, then the first test that we would run is the cable test, and here we see a cable test result. Starting at the top, we have the length of the installed cable. This is end-to-end. The remote identifier, the wire map shown end-to-end again, and the available bandwidth in the speedometer, which in this case is showing that the cable is good for 2.5 gigabit per second Ethernet, although our ask was for 1 gigabit per second, hence the long segment. And then, of course, the save as stores the result for reporting and documentation. Of course, not every test result is a pass. Some of them fail. And again, we see length measurement, which is within limits. The wire map is fine, but the cable bandwidth performance is below our expectation. This particular cable is only good for 10 megabit per second Ethernet, and the reason is shown in small letters in the bottom left-hand corner. We have a return loss issue, an echo issue on this cable. So that would need to be investigated, troubleshot, and re-terminated potentially, or the cable may need replacing. Of course, where the cable goes is sometimes something of a query. We don't always know exactly where the cable runs. So built into the tester, we have a tone generator, which together with a tone probe enables us to trace the cabling run. We can follow it pretty much all the way along, or in the case of heavily shielded cables, we can at least find it at the patch panel. If the cable is already active, already plugged into a switch device, then we have the ability also to flash the port light on and off really, really slowly. It doesn't look like data. It doesn't even look like Morse code. It's a very slow, rhythmic switch on and off of the port light. But it does enable us to find exactly where we need to be. Beyond cable testing, we have the network test. So this is our switch test. We can identify the switch port, the switch name, virtual local area network ID, or VLAN, the data carrying capacity of the switch in terms of megabits or gigabit per second, whether or not there is remote power available. All of these parameters are saved as part of the report generation capability. When it comes to power over Ethernet, we have a lot of detail available, so we can determine what the switch is configured to deliver. In this case, it's configured to deliver class 4 power over Ethernet, which is 25.5 watts at the powered device. The onboard load test confirms that there is sufficient voltage to provide that power at the current state. Again, we save that data and we use it to generate our documentation. Documenting results is as simple as connecting instrument to PC, starting linkware, and we can then generate any kind of report. This is cable test. This is cable test when it fails, where obviously we're missing 4 conductors, which is not a very good thing. We also have the ability to produce the switch data report and the power over Ethernet report. That went fast. Now, we have a number of supporting videos which are available for download. They are available free for download. There is no charge. These are educational videos, so you are very welcome to visit them. The link is at the bottom of the screen there. We also have materials for download. I'm a particular fan of the poster on the left-hand side. It's an A3 poster if it's printed, and has a lot of useful information, particularly if you're looking at outlet configurations. So, what can we do now? Well, we can take the next step and actually show you a LinkIQ operating. We have one here. I configured it earlier, so we will move across and have a look at an actual test. So this is a LinkIQ. Where's my vertical shot? There it is. This is my hand. You can tell because it's mine. And I pre-configured this. I've connected this very stylish piece of cable, beautifully manufactured and prepared for us by Harting. And here is the remote wire map adapter. And all I have to do is press auto test on the tester, and the unit will produce quite quickly for us the cable length, the remote ID, which is that one, the wire map, which is correct, and the fact that this particular cable is good for everything up to 10 gigabit per second Ethernet. Now I can save that data if I choose to. Equally, I can move on from that, so I'll hit save as, we'll call it cable sample 3. The project name is saved as Harting IE Week. I'm the operator, so I hit OK, and the result is now stored in the tester, one of several hundred, which I can download and convert into a test report. As an alternative, we can also change cables. So we can go, this particular cable, also beautifully manufactured for us by Harting, is a hybrid, RJ45 at one end and M8 at the other. So given that we were using the same test as before, this is a 2-pair cable, so it does not necessarily pass. So what I'm going to do is reset for 2 pairs, which is this one, and here we can see this is a 5.2 meter cable. Test result is a pass. We only have 2 pairs on the cable, and it is good for 100 megabit per second Ethernet, which is exactly what we asked for. Once again, I can save this result, and we're good to go. Now, we could test many more cables if we had more time, but I think we're probably at the point where it makes sense to stop and ask for questions, comments, and say thank you for having us.
So, thank you very much.
Thank you for having us here.
Very interesting. Crossing my fingers for great success of the product.
Thank you.
Thank you very much. And if there are questions, we will pass it to you afterwards.
We will answer.
Yeah? Thank you.
Thank you.
Perfect.
Have a nice day.